Okay. What's another thing that there's another thing I'd like to talk about now, which is like what is involved inside the guts of Java that allows multiple calls to the same method and then kind of like remembers, like when you call summation recursive of one from summation recursive of two, there's some memory that remembers that some summation recursive two was called, like somebody else called summation recursive of two, and there's some memory that knows that there's this expression two plus summation recursive of one that hasn't been resolved yet, and all these other expressions that haven't been resolved as the recursion takes place. So that memory is called the stack. And in order for recursion to work, you need this thing called the stack. So Java has a stack which remembers things about methods that have been called that have not been resolved yet. All right. So there is a stack for summation recursive of five. There's memory. So let me put it this way, another way. Each call to a method allocates some memory to the method for things like local variables and unresolved expressions. Okay? So when we call summation recursive of five, and part of the execution of summation recursive 5 is this recursive statement that says it's n plus summation of n minus 1, or 5 plus summation of recursive 4. Well, at that point, we need to leave the method summation recursive of 5 and start figuring out what's going on in summation recursive of 4. And so the stack remembers the stuff about summation recursive of 5, but then allows us to get into resolving the call to summation recursive of 4. And when it calls summation recursive of 3, the stack remembers things associated with summation recursive of 4 and resolves summation recursive of 3. And that process repeats for each successive call, recursive call. All right? And then what happens when we resolve summation recursive of 1, the stack then for summation recursive 1 is freed up. It's not going to be used anymore. We return the value of summation recursive of 1 back to summation recursive 2. Control goes back to summation recursive of 2, and the memory that was associated with this unresolved expression is still there. It's stored in the stack, and we can resolve that expression. Likewise, we end up, thanks to the stack, resolving all these expressions. Okay, so where am I headed with this? Well, I'm headed to something really kind of interesting. So let's write, so I've talked about what can happen when you have an infinite loop, all right? If you have an infinite loop, either a for loop or a while loop that never ends, like while true, all right, and some code inside that while true, and that code just runs over and over and over again inside your program. When you have that, what happens is that the program begins to occupy more and more of the attention of the CPU. CPU is like, okay, okay, I'll give you some more time. Oh, you want to keep running? Okay, I'll keep running, keep running, keep running. And pretty soon you end up in a situation where the fan on your computer starts to go on. If it's a laptop, you might notice that the laptop's actually getting warm. If the laptop's actually sitting on your lap, it's going to get warm. You'll probably notice that the battery starts draining pretty rapidly. So that's just as an interesting aside, that kind of infinite loop idea is something that I toyed with for a smartphone, because you could write a little program on a smartphone that ran an infinite loop, and the battery would start to drain, and the phone would start getting warm, and I was like, that'd be really cool, like just to warm your hands, right? Like if it was a cold day, you could warm your hands by having an infinite loop running on your phone. I was like, wow, what a cool app. So I went to the App Store, and of course, there's like a million apps there. And sure enough, there were like three that were hand warmer apps that were basically that, just write an infinite loop, do a while true. You could do that. You could have your own app called Hand Warmer 5 that basically is an infinite loop in a small app that runs on your phone. All right. So for something like a while loop or a for loop, we've got this CPU utilization that happens. All right. But what happens if you have infinite recursion? Okay. So what happens if I modify the summation example and I create infinite recursion? Right. So we're going to modify summation, and we're going to have the following rule and this rule only. Summation of n is equal to n plus summation of n minus 1. That's all right? So we are never going to hit this base case here. Base case always stops the recursion. We're just going to keep the summation going. So that means the summation recursive of 1 so let's say we did, just as an example, okay, we have the summation recursive of 5 is 5 plus summation recursive of 4, and that continues for a while, and then we end up getting down to summation recursive of 1. Instead of triggering the base case, which stops the recursion and says, hey, summation recursive of 1 is 1, we're going to say it's 1 plus summation recursive of 0, and then that's going to continue. Summation recursive of 0 is 0 plus summation recursive of minus 1. And it's just going to continue on and on and on forever. Okay? So what would you expect to happen? Would you expect to have something happen like a while loop or for loop where, because a method's calling itself over and over again, it takes CPU time to do that, and the CPU will start heating up, you'll hear the fan go on, the laptop will get hot, your battery will get drained. Is that the kind of thing you expect to happen? Well, let's try it. Let's do infinite recursion, right? So we'll call this summation infinite. All right, and so we'll set result equal to 0, and we'll call it summation infinite. And we're not going to have a base case. All right, so we're actually never going to be able to satisfy this expression. If I do summation of 5, that's going to be based on the summation of 4, which is based on the summation of 3, summation of 2, summation of 1, summation of 0, summation of minus 1, and it's going to go on forever and ever and ever. All right? Not really forever. Something's going to happen. The CPU is going to burn up your computer. The battery's going to drain. Well, let's see what happens, okay? So we'd like summation infinite to return something. Well, let's see what happens. Whoops. Whoa, that didn't do anything. Why not? Let's say. That's kind of anticlimactic. Let's compile this. It looks like summation infinite behaved just like summation recursive. Oh, I see what's going on. That's cool. I didn't call summation infinite here, so I got to make sure I have the method call itself. I was calling the other method. All right, now we should see some interesting behavior. Ooh, that's kind of cool. What the heck? All right. So there's something weird going on here, right? Let's go up a little bit. I think I can do it if I just drag this to show, whoops, to show that I'm interested in what happened above here. All right, I have some clever ways to do this, but let's go up, see how I, whoa, 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 whoa. Okay, so here at n equals minus 3,136, all of a sudden we see this thing that says exception in main thread, java.lang.stack overflow error. All right, so we got to get as far as n equals negative 3,136. So that's how many calls were made to summation infinite. It called itself 3,141 times because we did now 142 times because we did 6 calls before we went negative for n equals 5, 4, 3, 2, 1, and then 0. So we've done a lot of calls, but the program crashed, and the error we're getting is a runtime error that says exception in thread main Java lang stack overflow error. So what is that? What is the stack overflow error? Well, a stack overflow error, if you recall, that each call to a method allocates some memory to the method for things like local variables and unresolved expressions. And since we have every call to summation recursive triggers, or I guess we're calling this now summation infinite, right? Let me fix that. So each call to summation infinite triggers an expression that there's memory associated with that must be stored on the stack and held there until subsequent calls are resolved. That memory takes up space in the computer, and at a certain point, if you keep calling a method recursively and taking up a little bit of space for each method call for record keeping, then eventually, if you call yourself too many times, you're going to run out of space. So infinite recursion triggers something called stack overflow error. So when you're writing code and attempting to come up with a recursive solution to something, you may find yourself in a situation where you have a stack overflow error. It is not uncommon to have that. And by the way, that's why if you've ever noticed some of the Google searches you're doing when you're trying to learn stuff about Java, a common place where some of the answers to questions you're asking have been posted and answered is a place called Stack Overflow. And you see this, those little orange things are examples of chunks of memory that have been allocated to the stack of a program that's running. And that stack has chunks of memory associated with method calls. And if you have a recursive method that's gone crazy, you're going to get a Stack Overflow. All right, so now you know why this website is called Stack Overflow. Oh, and there I am. I have a little bit of a reputation, not a huge one, but yeah, I've answered some questions in the past. Okay, cool. So now you understand the basics of recursion. So we've done 2 examples, the factorial example and the summation example. And the things to note about these examples is that a recursive solution solves the problem using a simpler version of the problem or of the problem solution. And in order for it to work, we have to have a base case which stops the recursion, and then we can have one or more recursive cases. The computational power of a recursive solution to a problem is the same computational power as an iterative solution for repetition, a while loop or a for loop. Now, you might find recursion something that really connects with you better than a while loop or a for loop. Like you might just see problems as things that you can solve using recursion. I think that if you're a math major, for example, you might find that recursion is a really elegant way of thinking about problem solving. And often when you look at solutions to math problems, sometimes those solutions have recursion in them, a function which is defined in terms of a simpler version of the same function. All right. You might find that recursion is a little bit harder to think about, and that's okay. But it is a tool that we do use as computer scientists. All right, so the next lecture, I'm going to look at a more complex problem that we can solve using recursion. But for now, I think you've gotten a good start. The other thing that I wanted to say is don't be upset or concerned if you end up getting a Stack Overflow error. When you see that error, if you're programming, what it means is that you have not defined your base cases well, and you have too much recursion, and you need to go back and revisit your base case and see if you're triggering the condition that needs to be triggered in order to stop the recursion. All right.